Welcome to S11. In this one, we're just going to talk about non-permissible values, kind of pertaining to rational expressions. This could extend to other non-permissible values, but we're just kind of focused on rationals here. So procedure you can see there is going to be pretty simple. Rational functions we know it's going to be function over function. So we're going to factor them both if they factor. State the non-permissibles from the original denominator, and then simplify it, and then make sure we're holding on to all those NPVs at the end of the question. So let's kind of jump into a question here. First question is you see x squared minus 9 over x squared minus 5x plus 6. So we're going to start by factoring this thing. So x squared minus 9 over x squared minus 5x plus 6. So you can see this kind of ubiquitous factoring skills coming back yet again. This top is going to become x plus 3x minus 3. And the bottom is going to become x minus 2x minus 3. So from here, what I'm going to say is, well, cool, I have an x minus 3 that's going to divide out. And it will divide out. What I should do first, though, is I should note what can x not be at this point in the question. And my answer would be x minus 2 can't be 0. X minus 2 can't be 0. And x minus 3 can't be 0. In which case, I know x can't be 2 and x can't be 3. Now, you don't actually have to show that, but that's what I'm thinking. So I'm going to kind of just note that for myself. Hey, x can't be 2 or 3. Because my next thing is I'm going to divide out the x minus 3s. Perfect. They divide out to 1. Perfect. And that's going to leave this thing is equal to x plus 2 over x minus 2. Now, the really, really common mistake is going to be people are going to say, well, okay, x cannot be 2. Correct. But remember, we're basing our restrictions off the original function. The original function said x cannot be 3 also. So I need to include that in my final answer, right? I shouldn't be able to break that function at any point in the solution process, even though we've cleaned it up. And we talked about that in the core videos as well. But x equals 2, x is 2 and x is 3 are both not permissible values. If anything, to be honest, x equals 3 is probably the more important one, because we kind of know like in this course, you're going to look at that and you're going to say, like, as you look at that, you're kind of thinking x can't be 2 for sure, right? You kind of like just see that looking at the question. But if you're just looking at that answer, you have no reason to think 3 is a problem. So just be careful. Make sure you're stating those. Because again, our domain applies for the original function, not our cleaned up function. Okay. I'm going to pop one up for you to try. So here's yours. Be careful of my scroll here. Simplify and state non-permissibles, x squared plus 5x plus 6 over x squared plus x minus 6. The factoring is pretty clean again. This isn't a factoring exercise, but they could get worse. This is just the kind of core skill here. So pause the video, try that question, we'll come back for the answer. Okay, so there's the answer. So again, x plus 3 cleans up. At that point in time, my restrictions are locked in. So notice I'm going to say x can't be negative 3. That's the big one. And then also x can't be 2. That's the kind of littler one, but we're still going to keep it. One more example to try. So this one says, hey, simplify and state the non-permissible values of 4x squared minus 12x over 2x. So let's start. I'll just write the question out. So 4x squared minus 12x over 2x. So I'm going to factor this thing. On the top, I see I can factor out 4 and an x. This is just a common factor question, which is going to leave x minus 3 over 2x. Now again, just save myself at this point. This is when I should be kind of stating my non-permissibles. So I can see x cannot be 0, right? Because I know 2x can't be 0. That denominator can't be 0. So I'm also going to clean up now. So I'm going to say, well, the x's are going to divide out. 2 divides with 4 to leave 2 on the top. So this thing actually cleans up. It looks like a polynomial. 2 times x minus 3. And you could even go a step further and just say that's 2x minus 6. So when you look at that, you would have no reason to think there's any issue whatsoever with that function. There's no domain restriction. It looks like a polynomial. But then you're going to say, I remember once upon a time, x could not be 0. And that's kind of telling your reader as well, like, hey, something happened with this function. There's some reason x can't be 0. So we are making sure to include that in our final answer. And that's it. Thanks for watching. Quick checklist, just to kind of like finish off with. So remember those non-permissibles from the original denominator. This is cancel, really divide out. I don't like that word cancel. Divide factors, not terms, and carry those non-permissibles forward. That is it. Thanks for watching.